Now, let's get into the steps of conducting principal component analysis. First, download the data of the sediment pollution. The data sheet is an Excel file containing the heavy metals and it looks like this. Next is to transfer the data of the heavy metals from the Excel into the SPSS. Then, in the data view, copy and paste the data starting from the aluminium until cadmium. Rename the variables accordingly into its heavy metals in the variable view of SPSS, starting with aluminium,
eternity later,
cadmium. And then make sure to change the measure of the variables listed as Q.
A few moments later.
Now we are good to go to run the test for PCA. Go to Analyze, Dimension Reduction and Factor. Place all the variables into the variable box.
Later.
Then go to Descriptive, under Statistic, tick Initial Solution. Under Correlation Metric, tick Coefficient and KMO and Bartlett test. And then click Continue. Next, at the extraction, under Method, select Principal Component. Under Analyze, make sure to choose Correlation Metric. And under Display, select Unrotated Factor Solution and Script Plot. Under Extract, select based on eigenvalue greater than 1 and then click Continue. Then, click at the Option button. Under Missing Value, select Exclude Cases Pairwise. Then click Continue and OK. So this is the PCA output that we will get where we have the KMO table. Next, we are going to extract the components that have the eigenvalues of more than 1. In this table here, we can see that there are only 2 PCA components that has the eigenvalue of more than 1. So, to extract that, same steps as before. Click on the Extraction button. Under Extract, select Fixed Number of Factor. Factors to extract is 2, since only 2 components have eigenvalues of more than 1. And then click Continue. Then click on the Rotation button. Under Method, select Varimax. Under Display, select Rotated Solution and Loading Plots. And then click Continue and OK. So, these are the output that we will get. Next, click on the Option button. Under Coefficient Display Format, select Suppress Small Coefficient, Absolute Value below 0.3, click Continue and OK. So this is the output that we will get, where we have the total variance explained, component matrix, and the rotated component matrix. Next, we are going to build our own VF table. First, copy and paste the both tables of the rotated component matrix from the SPSS data sheets into the previous Excel file. There will be 2 rotated component matrix tables. One is the completed and the other one is incomplete. Make another copy of the incomplete rotated matrix table and unmerge all the cells.
A little later.
Discard the unimportant cells. First, copy the cells in column 1 which have the values and go to Sort and Select. Select the sort largest to smallest or even sort Z to A. After the values are sorted, copy the values together with its heavy metal component and then paste it to build the VF table. And then, same steps are repeated for the second column.
A little longer than a few minutes later.
Next is to remove the values that is repeated by picking the higher value and eliminating the smaller one. To finish the VF table, for the completed rotated component matrix table and fill in the values.
So much later that the old narrator got tired of waiting and they had to hire a new one.
Tomorrow.
Then, the final step is by filling the initial eigenvalues, the variance, and the cumulative in percentage from the table of variance we got just now. Lastly, edit the table borders to make it neat. Is the table that will be used in the discussion part later.